The star Betelgeuse, a pink, extremely large star positioned within the Orion constellation, has long captivated astronomers and skywatchers alike because of its massive size and luminosity. If Betelgeuse were placed where our Sun is, it would extend all the way to Jupiter's orbit, showcasing its immense dimensions. Despite being about 642 light-years from Earth, its sheer size makes it one of the most prominent stars visible to the naked eye in recent times. But Betelgeuse has shown some unusual activity, including surprising dimming and brightening cycles, which many scientists believe may indicate that the star is nearing the end of its life. The renowned physicist Brian Cox recently made a groundbreaking statement that Betelgeuse is on the verge of a catastrophic explosion, predicted to occur within the next 2 weeks. This event, known as a supernova, will mark the final stage of Betelgeuse's existence. However, it will present an extraordinary opportunity for scientists to observe one of the universe's most powerful and awe-inspiring phenomena. As a massive star nearing its end, Betelgeuse is classified as a red supergiant, one of the largest and most massive types of stars in the universe. It has been under observation for centuries, but its recent erratic changes in brightness have sparked speculation that it may soon go supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under the immense pressure of its own gravity, resulting in a massive explosion that releases an astonishing amount of energy, radiation, and stellar material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a specific kind of stellar detonation that occurs when the core of a massive star collapses. This core collapse initiates the release of neutrinos and radiation, which creates a shock wave that destroys the star. The explosion could be so intense that it may even be visible from Earth without the need for telescopes, possibly outshining the moon in the night sky for several weeks or months. While such an event would typically be dangerous if it occurred closer to Earth, the distance between Betelgeuse and our planet, about 642 light-years, means that, although the explosion will be dramatic and visible, it poses no danger to life on Earth. This event, however, promises to revolutionize our understanding of supernovae and cosmic phenomena. A supernova is one of the most energetic occurrences in the universe, releasing more energy in just a few seconds than our Sun will emit over its entire lifetime. Betelgeuse's explosion will not only be a spectacular celestial show but also an invaluable scientific event. Researchers are eager to monitor this rare incident from the very beginning, using various ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation, ranging from visible light to gamma rays. One of the most important aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light from the explosion itself, due to their ability to pass through almost everything without being affected. Observatories like Japan's Superkamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. Additionally, the explosion will provide crucial insights into the formation of heavy elements. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will allow researchers to observe this element creation process in real time, which is vital for understanding how planets and the universe's chemistry come together. Although Betelgeuse's supernova is not expected to have harmful effects on Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could generate stronger auroras, increasing the regions where the northern and southern lights are visible. While these cosmic rays could potentially interfere with satellite communications and some technologies on Earth, any disruptions are expected to be minor and brief. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on the planet, not just professional astronomers with high-tech equipment. For weeks or even months, Betelgeuse is predicted to be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will not only captivate the scientific community but also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have long speculated about the death of Betelgeuse, but Brian Cox's recent statement adds a sense of urgency to the situation. In the coming weeks, observatories around the world are preparing to monitor every stage of the supernova, and the data collected will be invaluable, potentially transforming our understanding of stellar evolution, core collapse, supernovae, and the distribution of cosmic matter. Betelgeuse's supernova will also offer a rare opportunity to refine our models of cosmic distances. Being relatively close to Earth, it provides an unprecedented chance to observe how energy from such an explosion travels through space. By studying the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exists between stars, astronomers will gain a clearer picture of the universe's scale. This event will also offer a golden opportunity to study dark matter and how it may affect supernovae. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the nature of dark matter. The role dark matter performs in shaping the universe. Betelgeuse's supernova can even take us towards expertise in the lifestyle cycle of stars, mainly how huge stars contribute to the advent of the elements important for existence. Supernovae are the #1 cosmic events liable for spreading heavy elements throughout the universe, elements that finally shape new stars, planets, or even lifestyles. By analyzing Betelgeuse, scientists will gain important facts on how these elements are solid and dispensed. The cultural importance of Betelgeuse's explosion is profound. For millennia, human beings have appeared to the stars for steering, notion, and even meaning. The disappearance of one of the most prominent stars within the night sky will prompt philosophical reflections on the brief nature of the universe. Betelgeuse has been a consistent fixture inside the constellation Orion for as long as humanity has located the stars, and its absence will function as a powerful reminder of the impermanence of all matters. In a few cultures, such celestial occasions have been seen as omens or signs of cosmic exchange. Betelgeuse's explosion may evoke a combination of awe, fear, and marvel as humans from all walks of lifestyle witness a star's dying. This splendid occasion will probably reignite interest in area exploration and astronomy, drawing greater human beings into the pursuit of knowledge about the universe. Newbie astronomers are already making ready for the occasion, as contemporary generation permits virtually anybody with a camera or telescope to look at and file the supernova. This democratization of science will unite people throughout the globe, all watching and recording the equal cosmic phenomenon from their specific vantage points. Betelgeuse's explosion is not only a novel astronomical event but also a stepping stone for future area exploration. The knowledge received from the supernova will have an effect on how we examine different stars, in particular as we mission deeper into the area with missions to other planets and stars. Expertise in the existence cycles of stars and the dynamics of supernovae is essential as humanity appears to extend its presence past Earth. Additionally, the explosion will reignite interest in the look for extraterrestrial existence. Supernovae play a critical role in distributing the factors vital for lifestyles, consisting of carbon and oxygen, throughout the universe. By reading Betelgeuse's explosion, scientists can gain a better understanding of how the elements for life would possibly spread to other planetary systems and potentially spark lifestyles somewhere else in the cosmos. The approaching explosion of Betelgeuse is shaping up to be one of the most substantial astronomical events in our time. Its supernova will offer a wealth of scientific statistics, enhance our knowledge of the universe, and captivate human beings worldwide. Although Betelgeuse's demise will mark the end of a massive superstar, it'll also signify the continued cycle of introduction and destruction that governs the cosmos, a reminder that from death, new stars, planets, or even existence can emerge. As we watch for this monumental occasion, the arena will be looking at the night sky, looking forward to the moment when one of the universe's maximum effective forces bursts into view. For both scientists and stargazers, Betelgeuse's final act might be nothing short of audacious-inspiring as Betelgeuse approaches the final degree of its existence. One of the extra speculative yet fascinating possibilities surrounding its drawing-close explosion is its capability to shed light on a number of the universe's finest mysteries: dark matter and dark strength. These elusive forces are believed to account for the widespread majority of the universe's mass and energy, yet they continue to be poorly understood. Some scientists speculate that supernovae, just like the one expected from Betelgeuse, may additionally hold the key to unlocking a number of those mysteries. Supernovae release an incredible amount of energy and radiation, and some researchers consider these effective forces should have interaction with dark matter in approaches we are able to look at and take a look at. One charming speculation is that dark matter exists within the shape of weakly interacting big debris, WIMPs. If WIMPs do exist, their interplay with the power generated by Betelgeuse's supernova should offer critical clues to their nature. This sort of discovery could be groundbreaking, presenting the first direct proof of dark matter, an elusive phenomenon that has confounded scientists for decades. In addition, Betelgeuse's explosion could provide insights into the nature of dark strength, the mysterious pressure driving the accelerated enlargement of the universe. By studying how light and power behave during the supernova, scientists may additionally acquire important statistics about how cosmic occasions like these affect the universe's enlargement and how they might be linked to dark energy. The approaching explosion of Betelgeuse offers a completely unique attitude on the life cycle of big stars, which play a crucial role within the cosmic atmosphere. Crimson, amazing giants like Betelgeuse are uncommon, making their study important for knowledge of stellar evolution. These stars shape from clouds of gas and dirt that disintegrate below gravity, finally igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they enlarge dramatically, dropping their outer layers via effective sun winds. This mass loss contributes to the enrichment of the interstellar medium, paving the manner for the formation of new stars. While Betelgeuse goes supernova, it'll not only provide insights into its own life cycle but also function as a cosmic laboratory for studying the conditions beneath which stars stay and die. Researchers will closely screen the aftermath of the explosion to decide whether or not a neutron megastar or black hole forms at its core. The nature of this remnant will offer treasured information about the physical approaches that govern the final levels of stellar evolution. The dynamics of the explosion itself will even offer a wealth of statistics. The surprise wave produced by the supernova will sweep through the surrounding fuel and dirt, heating it and causing it to glow brightly. This emitted mild will offer astronomers clues about the factors synthesized at some stage in the explosion, including iron, nickel, and other heavy elements. By studying the spectral signatures of those elements, scientists could be able to determine their abundance and distribution, deepening our expertise of how these factors propagate via area and contribute to the formation of destiny stars and planetary systems. Another location of interest is the ability for gravitational wave detection. As the middle collapses and the supernova unfolds, it may generate ripples in spacetime that may be detected by observatories like LIGO and Virgo. Gravitational waves convey facts about the dynamics of the event, potentially imparting new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion can also act as a catalyst for technological improvements in astronomy. The predicted surge of observational information will probably push the bounds of modern-day astronomical instruments, potentially leading to breakthroughs in imaging generation, statistics processing, and actual time analysis. These innovations could benefit extensive variety of astrophysical studies beyond just the fostering a sense of surprise and interest about the universe. Academic applications, outreach tasks, and citizen technological know-how tasks can use this event to inspire the subsequent technology of astronomers and physicists. Schools and universities may additionally arrange viewing events, lectures, and discussions that emphasize the importance of expertise in the cosmos in our region. Within IT.as we put together for this monumental event, excitement is building during the scientific community and amongst amateur fans. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, mission our expertise of the universe, and unite us in our pursuit of knowledge. The loss of life of a celebrity becomes a profound reminder of the cycle of creation and destruction that defines the cosmos, urging us to reflect on our very own life and the mysteries that lie beyond.